Hello, this is Dr. Hassan Abdullah with the course Introduction to Natural Language Processing. And this is the part A of lecture 1 on basics of natural language processing. So, this is the supplemental website www.easymcq.com/goget. And I'll briefly tell you about this supplemental website also, which is going to be used for execution of this online course. So as you can see, the list of topics which will be covered in this course. So it's a quite a comprehensive list, and we will cover all of these cutting edge topics. So the topic which we'll be covering in this lecture is the basics. So basics is going to touch upon many of the topics which are listed in this course outline. So this is the learning management system which I mentioned. And as you can see, there are quite a few very useful and powerful and effective features in this learning management system. And you can read this. And in addition to reading, there are 6 lectures which covers those 8 powerful features of this LMS. And of course, I would suggest you to review these videos on how to use this learning management system and actually use it while you go and execute this course. So now I move to the easymcq.com GoGet. So this is the learning management system easymcq.com/GoGet. And as you can see, there are quite a few courses here in addition to natural language processing. There is data structures and algorithms, there's machine learning, there's AI. So you are welcome to make use of these courses. So now we move to the course of our interest, which is natural language processing. So these are the topics which we'll be covering in this course. So this is the name of the topic, and these are the questions and answers which are included in this topic. So Q Basics has 22 questions and answers, and of course there are other topics such as machine translation, which has 38 questions and answers. So it's quite a comprehensive course, and I'm sure you will enjoy it. And it is covering cutting edge topics and cutting edge content, and of course you will know of it. So the basics. So the first Q&A is, what is natural language processing? So natural means the language which the humans speak, as we of course we understand it also. And it is just not possible to just use the language which we are speaking. Computers cannot directly use that language. So these are some of the key components of natural language processing. So it means there a lot of processing has to take place with the natural language as which we humans speak before the machines can understand them. And of course, that before the machines can do something with what we want the machines to do. So this is the key components, which are like 8 components. These are not the components. Say for example, machine translation, sentiment. These are the applications. So, and of course, we will go into lots and lots of details so that you understand. So text processing, tokenization, breaking the sentence into small pieces, stemming and lemmatization. What does the pieces actually mean? Key components of natural language processing are the first 4 ones, and the next are some of the applications. And of course, there are quite a few applications. So these are the applications which we will be spending more time. So machines cannot just understand what we say, they have to process it. So the first part is text processing. Text processing, tokenization, breaking the sentence into small pieces, meaningful pieces, and stemming and lemmatization. What do they actually mean, right? For example, I'll be covering all of these things. Uh, Reducing the words to the base or the root form. And then is the stop word removal, like the, it, us, and so on. Us is the may or may not be. And then is the syntax analysis. Syntax, what does the syntax analysis mean? Understanding the sentence structure and grammar. What are the nouns? What are the verbs? Of course, that requires a lot of smart techniques. And then is the semantic analysis. So, what does semantic analysis mean? Understanding the meaning of the words. A word sense disambiguation is a big challenge. For example, I can give you many examples. As a matter of fact, there can be a full topic on word sense disambiguation in the context of semantic analysis. For example, what does break means in a sentence, or as I speak, brake versus break. What does mail room means? As I speak, as I write, I can write mail mail room or male mail room, and so on. The list goes on. And then is the named entity recognition. So in a sentence, if there is a name of a fruit, so that fruit is actually a fruit, or I am referring to a brand name of a product. And of course, there are many challenges. And then is the machine translation. Machine translation. What does the machine translation means? Automatically translating text from one language to another language. Sentiment analysis. For example, what is the sentiment? Is it positive or it is negative, or it is hard to identify? For example, if there is sarcasm, I bought a couch in which I sank, and people have to take me out. So there is sarcasm in here. And then is speech recognition and synthesis. So what I say, how the machine can understand it. And of course, the machine generates speech. And of course, it should sound like human. And text generation, like by chatbot summarization, creative writing. This is very, very hard in the context of many powerful tools around, and which generate text, which can generate code. And they are having a tough time generating jokes, but generating poetry also. So these are the applications. So, what are the differences between natural language? And of course, I forgot before I forgot. So, these are the references. So, if you are interested in further reading, so these references are not restricted to a single book or a single website. In certain cases, they are websites also. So, what are the differences between natural language processing and computational linguistics? So, there are quite a few differences. There are different things. For example, if you look at the definition, natural language processing is a branch of artificial intelligence. That is not the case for linguistics, and works with algorithms and machine learning, okay, and solving real life problems and understanding what we are saying. Computational linguistic, theoretical and scientific study of the knowledge. Linguistic structure, okay, bridging, of course, linguistics with computer science, we explore interesting things, but the primary objectives are very different. Primary objective of NLP is language to use effectively with machines to solve real world problems. Linguistic is a deeper understanding of of the language phenomena. Approach is very different. We have part of speech tagging, we have named entity recognition, we have different models, we have language models, and the list goes on. But the approach or the methodology of computational linguistics is different. Working with grammars and syntax trees, we will also be working with syntax tree, but the focus and the objective will be different. And if you look at the application examples are many different. Text classification, spam detection, parsing, and so on. And this figure is a good example how NLP. See the NLP, we can see NLP dealing with human language, computer science, deep learning, AI. This is which is not the case for linguistics. So these are some of the references. Books references are there, papers are there, and websites are also there for your benefit. So why NLP is so hard? Why it is so hard? It's a complex problem, and there is lot of ambiguity. So instead of having a full topic on ambiguity, which could have like 30 or maybe 40 Q&A and might have overshadowed the entire course. So what I have done is throughout the course I have been mentioning the ambiguity, and there are different types of ambiguity, and I will also give you examples. And then there's the complex syntax and grammar of the human language. It could be the language English or German or Chinese or Urdu language, whatever that language could be. Ambiguity of pronouns and references. So ambiguities are always there, which is, and I'll go into more details. Variability in a language, which vary from a language to language. What is the standard subject, object, verb? It could be object, verb, subject, or some other combination in some other language, and the tools or the techniques which you have developed for a certain language may not work in that other language. Ambiguity in named entity recognition. I'll go through it again, and there's a full topic. And then is the polysemy homonymy. Polysemy, I have the word which have the same spelling, bat versus bat, which is an object of bat, which is an object of sports, and bat as a mammal, and of course bank versus bank, and then of course is the break versus break. The words sound same, but the spellings are different. And noise in data. There could be spelling mistakes, there could be jargon, there could be other issues, and multilingual challenges, which I mentioned across different languages. And biasness in data. What data was used to train the systems, train the application, and the resource intensity is the tremendous amount of computational resources which are required. So ambiguity, I've given you ample examples. For example, syntactic ambiguity. I saw a man with a telescope. So I saw a man through a telescope, or I saw a man having a telescope. and the list goes on. Contextual understanding. So the word is recognized by the company it keeps, but that is not very simple. There, for example, I can give you hundreds of examples. Uh, the glass fell on the floor and it broke. The hammer fell on the floor and it broke. So there is no hint of the context, none whatsoever. We know by our knowledge that if the glass falls on the floor, the glass will break, the floor will not break. And that knowledge has to be available, codified, accessible, linked. It's a difficult problem. And then the ambiguity in pronouns and references. So John went to the shop, and John and Sam went to the shop, and he bought him a gift. Who is he, John or Sam? Variability in languages, lack of knowledge, which I've already mentioned to you. So we see that there are many challenges and there are many issues with natural language processing, with multilingual challenges, different lexicons, different syntactic rules across the languages, and there is less commonality. And the biasness in the data itself, biasness based upon the gender, based upon the racial, based upon the culture biases. So the corresponding results are dependent upon that biasness. And of course, we need a lot of resources. So here are some of the references if you are interested in reading more. So what is the combinatorial explosion challenge in NLP? Combinatorial explosion means that there is sudden and there is a large increase in the complexity of the problem. So what are those issues? One is the vocabulary explosion. A vast number of lexicons and their combination basically results in many different sentences, and the polysemy and the ambiguity of the meaning, and their combination of course is adds to the complexity of the already complex problem. So these are the points which we'll be discussing in the Q&A, and I'll discuss the numbers with you. So first, just look at the vast lexicon. The human language has vast vocabulary. And then we have these plural versions of the word, which add to the complexity of the problem itself. And then we have this hundreds of thousands of words, which expands exponentially when we look at these replay versus replayed versus replaying. So you see that replay and with this all of these variations, these derived forms, they increase the permutations, the number of permutations, and the ambiguity in the meaning of the word, they also increase the complexity of the problem. For example, the mail room, mail, as I mentioned before, versus the mail room. So which of the mail room the person was mentioning, of course that requires the meaning of the word and the context also. And is that the word sense disambiguous. So if we have a sentence with 10 words and average of 5 possible meanings, so we have 5 power 10, approximately 9.77 million different meanings. Now the problem is that problem and the solution is as complex because we as humans, we don't work with the permutations. We listen to a sentence, we read a sentence, and we know that what should be the correct meaning and what should we not be looking at or not be considering, but we don't know how it works. So that's why we cannot code it. And then is the word combination and co-locations. For example, when we say strong coffee, we don't say strong milk, or don't say strong juice. So the strong coffee is, and of course, if we look at the permutations and the combinations, then of course the strong can come with many other drinks also. So how would the machine knows that which combination? Of course, if you make it a rule based, that is going to create more problems because rules have their own complications. Then the contextual meaning, what does the bark mean? The bark reference to the dog or the bark reference to the skin of a tree. And named entity recognition, for example, Paris is, when is being referred, the Paris is the name of a city or the Paris is the name of a person. And then is the machine translation vocabulary. So a sentence with multiple ambiguous words can result in many possible translations. So which of the translation is the one which is relevant and which we were looking for? And then of course is the out of vocabulary words, the words for which the system and the application was not trained. So this is I will just briefly zoom it. No need to, but what you can see is that the as the problem basically you add the more and more the vocabulary increases. Okay, so the complexity of the problem, as a matter of fact, increases exponentially. So basic types of ambiguity in natural language processing. So these are technical terms, right? And I have over here explained those technical terms, and let's look at some examples. Okay, referential integrity, referential ambiguity arises which entity a pronoun or noun refers to in a given context. So let's look at these examples of which are defined over here. So lexical, I saw her duck. So I saw her duck is I saw her ducking from the ball, or I saw her walking with the duck, right? Chicken is ready to eat. So this is inside the statement. So over here, the word had different meanings, but it is in the sentence. The chicken is ready to eat. So this chicken is ready to eat, or the chicken has been cooked and is ready to eat. Then part of speech, chair, noun or verb. So this is a chair, a person who is chairing an event, or a chair as an item on which a person sits. Syntactic structure. I saw a man with a telescope, which I've already mentioned. So the man was carrying a telescope, or the man was seen through a telescope. And John gave Bill his book. So this is very confusing. So John gave the book, or the Bill gave the book, right? So referential constraint. So the referential issue is here. So now let's look at more challenging questions and answers about the basics of natural language processing. So this is an interesting question. Five interpretations of the statement, I made her duck. And there can be more also. The point here is that we can make certain interpretations, but how about the machine? So I cooked duck for her, that's one interpretation, I made her duck. I cooked the duck which belonged to her, cooked her duck. I created a toy duck for her, or I drew a duck for her. That could be another meaning. I caused her to quickly lower her head or body, right? And I magically turned her into a duck. So I have spoken about six, there can be more also. The question was about five. And these are some of the references which can help you more. So, what is the problem of scale in natural language processing? This is similar to the question which we have already looked at, but the problem is so profound that I have to spend some more time on it. So, the data size and the scale is the how much the scope of the problem, so to say. So, the size of the data and the variety itself, right? It's the variety itself. I'll give you some numbers also, and then the vocabulary, and of course, the word has a certain meaning in a different context. So, contextual variability is there, and it requires a lot of computational resources. It is a complex problem, and these resources may not be available everywhere. So we need to have the training data, and that training data does not have to have any biases, and it has to be enough training data. And then is the size of the model based upon which that training data is going to be utilized. And then is the generalization. Generalization is a key concept of machine learning, where based upon what is already been seen, okay, the what unseen is basically generalized what it could be, and how it affects the scale, the scalability, and the overfitting problem. So let's look what is meant by the overfitting problem. The overfitting problem is generalization and the scalability. Large data sets, complex models lead to overfitting problem. Overfitting means that a class is assigned even to what does not constitute something which is of utility. That's overfitting. So when you have lots and lots of data, okay, then overfitting does get a problem because it includes those say vocabulary or the words or the sentences which could be noise. And the scaling solutions, so one solution is the pre-trained model like the BERT and GPT-3 and so on. Okay, they allow better generalizations and efficient data representation, word to vector or GloVe. And of course we will be discussing simpler models also, which is a bag of words model, but they have their own limitations. So, what is the issue of expressivity and expressiveness in natural language processing? So, capturing subtle nuances of the meaning, shades of meaning, and those shades of meaning, of course, we humans can understand them, and how to make the machines understand those meanings. Representing linguistic structures. So, shades of meaning catch subtle nuances. For example, he physically kicked a. So you say he kicked the bucket, so the person died, or the person actually literally kicked the bucket. And handling the context, what is the bat as a mammal or a bat as a sports instrument. The chicken is ready to eat versus the chicken has been cooked. And multimodal expressivity. So when we speak with our tone, we speak with our head movement, with our eyes, with our body movement. But that is not there in a text message. Okay, that is there in a video. So and that is it's a complex problem. Yes, we are looking at video and of course natural language processing, so increasing the complexity of the problem. And limitation in real world understanding. Okay, for example, a model may understand a sentence syntactically but fail to understand the knowledge needed to interpret it properly. Like I mentioned that, for example, we go out and the grass is wet. So the grass is wet due to the sprinkler, or the grass is wet due to the to rain, or due to something else. It will depend upon many things, because if it's winter, then the grass might be wet, not due to rain, something else. If it's rainy season, then of course it's rain. So where is that knowledge in the statement the grass is wet? What is the impact of expressivity in translation? We could get funny and we can get strange translations which are irrelevant, okay, which doesn't fit in it. And of course, when we are performing information retrieval, the meaning of the search results can affect the quality of what we get. So this is just a small joke. So the way something is spoken and the way it is interpreted or the way it is generated is a whole makes a whole difference. So what is meant by corpora, and give simple example. So corpora basically is consists of a kind like a text bank on which different models are trained, and there are different corporas. They have different characteristics, and common crawl is based upon the web. And we have a text corpus, and so corpora is a collection of corpus, annotated corpus, where something is added to the words, to the sentences. And of course, role, they are used for training the models, language understanding, and many things, and linguistic research. So the details are here. And of course, then we have this tutor corpus, which has their own tags, which have their own slangs, and which have their own, so to say, these memes, and also, so how to make the model train on all of them. So it's a very we have a kind of a solution, but the scope of the solution is wide. So what are the features of a good corpus? It should be representative of the scope of the problem which we are addressing, and the size should be reasonable, and it should be sufficient, and it should carry the meaning also, and it should be annotated. Cleanliness and consistency, it should be clean of noise and spelling mistakes, and do some exceptions which are not very frequent. And it should be relevant, it should be domain specific. So if we are looking at a corpus for law, it should be more towards law instead of sports. And it should be accessible, and it should have the rich metadata, the data about the data itself. So we see that the problem has a solution, but the solution is also kind of complex.